Hello everyone. In this lecture we're going to discuss selected material from chapter 13 of your text. This is our last chapter. In this chapter we focus on judgment, decisions, and reasoning. Now first let's define decisions and reasoning. We define decisions as any kind of choice process in which we have to decide between alternatives. And reasoning is kind of how we do that. So it's the process of drawing some conclusions about the alternatives that were given in order to get us to making a decision. Now, the first type of reasoning we'll look at is inductive reasoning. So this is reasoning that's based off of some observation that we make. And we reach conclusions from evidence that we get from observing. Now, the strength of argument in inductive reasoning is based off of three things. So how representative the observations that we have made are to the actual judgment that we have to make. Also the number of observations that we've made, and also the quality of observations that we made. These three things kind of go into how strong of an argument we have to make a decision for one alternative over another. And we use this type of reasoning to do a variety of things. So we use this type of reasoning for scientific discoveries, for example. So making hypotheses and general conclusions. We also use this type of reasoning in everyday. So making predictions about what will happen based off of an observation about what has happened in the past. So if we've made an observation about something that's happened before, we're making some sort of a prediction or judgment about what's going to happen now based off of that past experience. Now, something we use quite often is something called heuristics. Another way to think about heuristics is rules of thumb, if you've heard that statement before. Basically, it's just kind of a general jumping off point to making a decision about something. So really, if you've ever heard, well, basic rule of thumb for this is, and then whatever it is. If you've heard that saying before, basically it just is kind of a guideline, a general guideline for getting a correct answer to a problem. But again, it's not always foolproof. It's a general way of getting to a correct answer. And they can be helpful because a lot of the times they will work. Now, two common heuristics that are used are the availability heuristic and the representativeness heuristic. First, we look at the availability heuristic, and this is just stating that events that are more easily remembered are typically judged as being more probable to occur than those less easily remembered. So if you remember events or have encountered them more often, you're more likely to judge them as being more probable of happening. So here, for example, we have a list of causes of death, and the ones over here are more likely to occur than this column here. So homicide is more likely to be a cause of death than appendicitis, for example. And over here we have percent of people picking the less likely option. So only 9% of people picked that people were more likely to die of an appendicitis than homicide. So people did well. 91% picked the more likely cause of homicide. Now, this could be because we see homicide a lot in the news, but we don't see appendicitis deaths a lot in the news. So we could explain it that way. But if we look down here at one of these other options, we see asthma. People are a lot more likely to die of asthma than from a tornado. But 58% of people said that people are more likely to die from being exposed to a tornado. Or the effects of the tornado. So people basically chose incorrectly here. Now, again, we can think about the news and how often things are reported. You're more likely to see when a natural disaster like a tornado occurs, you're more likely to see that in the news than you are people who die of asthma. So it could be just exposure to more deaths related to a tornado that led to this decision. And also, people are much more likely to die of an appendicitis than pregnancy, but 83% of people said that they thought pregnancy was a more likely cause of death, which is way wrong. But I think that because it's more rare and maybe a bit more shocking and could be more tragic way of dying, this tends to be more exposed in the news and in papers and such. So people tend to see this more than they do deaths of appendicitis. So this is just an example of how this heuristic works. And while it does serve people well in some instances, like up here, it doesn't always lead to a correct determination, like down here. Now, another heuristic is the illusory correlation. So this is when we think a correlation exists between two things, but it either doesn't exist or it's much weaker of a correlation than what we think. So, for example, stereotyping. So we typically think about this as being just oversimplified generalizations about a group or a class of people that often focuses on negative aspects of that particular group. Now, most of the time, we assume that the correlations between whatever aspects of the group we're looking at and the group itself, we think that the correlation between those things is much stronger than what it actually is, or perhaps maybe that correlation doesn't exist at all. So that's basically the idea behind an illusory correlation. Now we look at the representative heuristic. So this is where we have a judgment of an individual being based off of how well that individual reflects the properties of an entire group. So basically, we can think about it like the probability of individual A, being a member of class B can be determined by how well the properties of the individual A resemble properties that we normally associate with class B. Now, we will use base rate information about that individual to make the determination if they are in Class B, if that's all we have available. Now, if we are given descriptive information, so just more information in general about individual A, if we have that available to us, we will disregard base rate information and just go off of descriptive information to determine whether or not individual A belongs in Class B. And again, this is based off of how well they resemble what we think Class B should be. Now we move on to the conjunction rules. So this is just stating that the probability of two events can't be higher than the probability of the single constituents that are making up the two events. So if we have, for example, here we have bank tellers and feminist bank tellers. Now, of course, it's a much smaller subset group here that are feminist bank tellers. Now, because of that, we can always say that it's much more likely that somebody is a bank teller than somebody is a feminist bank teller. But in all, we can't say that the probability of two events added together is higher than the probability of the two single constituents. Now we look at law of large numbers. So this is stating that the larger the number of individuals randomly drawn from a population, the more representative the resulting group will be of the entire population, and that makes sense. So the more individuals from a population you sample, the more representative your sample will be of the full population. Next, the my-side bias. So this is a tendency for people to generate and evaluate evidence and test their hypotheses in a way that is biased toward their own opinions and attitudes. And this is something that can happen in research. We really strive for this not to happen, but this can occur. This has occurred in a variety of published papers. This is something to really try to avoid if possible. I think that it could be something that even happens without people realizing they're doing it. But of course, this isn't leading us to the best science, as you can imagine, when it's heavily biased towards someone and they're basing how they test their hypotheses based off of their own personal bias. We may not be getting to the correct conclusions by falling into this particular bias. And the last would be the confirmation bias. So this is the tendency to selectively look for information that conforms to our own hypotheses and overlook information that argues with it. Now, I think this time of year, well, not even so much this time of year, but this point in time, as we're coming up on a presidential election, I think that we see this kind of thing quite a bit. If you notice, this day and in time, a lot of news networks are very much either a conservative or liberal, and I think there was a time where that wasn't so, that news networks just reported the news. But now you have certain networks that are reporting more things that are much more conforming to conservative points of view or Republican points of view. And you have other networks that are more trying to appeal to liberal, democratic points of view. Now, as you can imagine, if you are a Republican, you're more likely to watch the stations that are reporting things that more go along with what you view as being correct, and vice versa if you are Democrat. Now, of course, this leads to a greater divide between the two parties, and I think this is just a really good example of the confirmation bias. And that, again, is that tendency that we expose ourselves to things we tend to agree with. We look for information that conforms to what we already think is correct and kind of overlook information that argues against what we already think. And here we're looking at an experiment that was taking a look at the confirmation bias. This was done in 1979, and they had participants read an article regarding capital punishment, and they recruited participants that either were in favor of capital punishment or were against capital punishment, and they were asked to read the exact same article. And those in favor of capital punishment found the article to be convincing, while those that weren't in favor of capital punishment found the article unconvincing. So this is kind of that just more verification that confirmation bias can happen, where even though they're exposed to, in this case, the same article and the same information, the previous assumptions that they have or previous beliefs are really biasing what they're taking from the article and whether or not they find the article convincing, because they're taking what conforms with their own belief and using that and disregarding anything that doesn't go along with what they think. And now we move along to expected utility theory. So in this particular theory, this theory assumes that people are rational, and if they have all the relevant information in order to make a decision, they will make a decision that results in the maximum expected utility, or basically this is referring to payoff. So the maximum payoff possible. Now, utility we can define more formally even as outcomes that are desirable because they're in the person's best interest. So, for example, maximum monetary payoff. Okay, so if you have options between different monetary payoffs, the idea with expected utility theory is if people have the relevant information they need to make the best decision, they will make the decision that results in the most money payoff or monetary payoff in this case. Now, one of the advantages for the utility approach is that we could have specific procedures that make it possible to determine which choice would result in the best monetary value. However, not everything is about money. So decisions aren't necessarily about money, and as we know, people find value in other things. So this is one issue for the utility approach. And also, as we know, many decisions do not maximize the probability of the best outcome for the individual. Plainly put, people don't always make the best decisions. Here we take a look at an experiment that demonstrates that. So here participants were given a choice between one of two bowls. So here in this bowl they have 10 total beans, 1 red bean. So the odds of choosing a red bean out of this bowl are 1 in 10 or 10%. This bowl has 100 beans, only 7 of which are red. So you have a 7 out of 100 chance of choosing a red bean, or 7% chance. Now, participants could earn up to $7 by choosing red beans out of a bowl. And again, they were allowed to choose which bowl they wanted to choose out of. And knowing all of this, participants chose this bowl more often, even though when asked, they were well aware that in terms of odds, they had a better chance, probability-wise, of picking a red bean out of this bowl. But they somehow felt that by choosing this bowl, because they knew there were more red beans here, that they had a better chance, even though we know, looking at the odds, that's not actually true. So this is just one example of how people don't always make the best decision, even if they have all of the information in order to lead to that best decision. Here's another example of this. This is called Deal or No Deal. This was a game show. I don't think it's on anymore, but it's a fairly recent game show, so I'm thinking most of you all would at least be familiar with it. Now, here, as you can see, the contestant is on the stage, and you see all these numbers back here. These are numbered briefcases. There's 25 of them. And the idea here is that there is $1 million in one of the cases, and the goal for the participant is to choose the case with $1 million in it. Now, once the participant chooses whichever case he wants, they start opening the cases he didn't choose, and all of the cases contain some amount of money. Now, as they're opening the cases, there's also someone calling down to the host to give offers to the participant to stop the game. Now, as they're showing the cases, if they're showing small amounts of money in those cases that they're showing that the participant didn't choose, then it seems as though it's more likely the participant chose a case that had a lot of money in it. Whereas if they're showing cases that have a lot of money in it, then it might seem as though the participant chose a case that didn't have a lot of money in it. And as you can imagine, that's going to affect the offers the participant gets to stop the game. So if they're opening lots of cases of small amounts of money, the participant's probably getting large amounts of money offered to them to stop the game. Whereas if a lot of the cases are showing large amounts of money, then the offers the participant's going to get to stop the game are going to be lower. And this is kind of where we find that emotions may play a role in decisions that contestants choose to make. So, for example, if they are doing poorly on this type of show, so they're having lots of briefcases opening, that have large denominations and it's looking like they chose a case that's not worth as much, they're more likely to take risks in order to see if they can obtain better offers, because at this point, large amounts are showing and they are getting low offers to stop the game. So they're more likely to be risky and continue the game. Whereas participants that are seeing low offers being shown in the briefcases are getting higher amounts of money offered to them to stop the game. They're more likely to be a bit more risk averse and to take the money and stop the game. Now again, things like this might happen because emotions can affect decisions that are made. Now, we have a big difference between expected emotions and the actual emotions people feel. So we have expected emotions. So this is kind of how people predict that they're going to feel about an outcome, like losing or winning, for example. And what we find is that people very often inaccurately predict their emotions. So here's an example of this. So this is before and after a coin flip. Now, people predict that they're going to feel pretty good in terms of happiness if they win, $5 win, for example, here, versus if they lose, they're going to feel really, really bad. Now, this is the expected emotion here. After the actual coin flip, we find that people only slightly exaggerate how good they're going to feel when they win, but they really, really overestimate how bad they're going to feel when they actually lose. Now, there are things like incidental emotions that occur. So these are emotions that are not specifically related to decision making. Now, these might be related to someone's general disposition or personality, just kind of how they are, or some recent experience they've had, or one's general environment or surroundings at the time of making the decision. And all of these things can affect someone's overall decision-making process. So the thing to note here is that there's lots of different emotional factors that can really play a role in how someone makes a decision. Now, also, decisions really highly depend on how choices are presented. Now, we're going to look at an opt-in versus opt-out procedure. So, for example, in our country, we have an opt-in procedure for being an organ donor. You have to make an active step to be an organ donor. So, when you get your license, for example, you have to request to be an organ donor and have them put that on your license. Whereas in some other countries, there is they do the opposite with this. They do an opt-out procedure. So basically, they're all labeled as being an organ donor unless they specifically request not to be. Now, what we find with this is that there tends to be a status quo bias. And this is the tendency that people have to do nothing when faced with making a decision. This is why we find in our country the majority of people kind of just go along with the whole process and don't take this active step to be an organ donor. So the majority of people in our country are not organ donors. Whereas in these other countries that have this different opt-out procedure where doing nothing makes them an organ donor, vast majority of their population are organ donors. So we find kind of the exact opposite given the procedure used. And again, we think this is kind of due to the status quo bias of people having a tendency to basically do nothing. Now, if we look at risky decisions, now we tend to find two different strategies used given how the problem is stated. So we find more often than not a risk aversion strategy when a problem is stated in terms of gains. So if we're talking about how much you stand to gain by making certain decisions, we find that people tend to be more averse or avoidant of risks. Whereas we find the opposite, we find more of a risk-taking strategy when a problem is stated in terms of losses, so how much you stand to lose. So just the different framing here of the different problems leads to two different strategies. Now, again, what I mentioned is a framing effect. So specifically, when we frame problems in such a way, decisions are really influenced by how things are stated. And this can obviously highlight a certain aspect of a situation. So if we look at this Tversky and Kahneman study in 81, they really looked at when situations are framed in terms of gains. And what they found again here was that people tended to be more risk averse or of risk avoidant. Whereas if they framed it in terms of losses, people tended much more likely to be more risk-taking. So just the way they framed the situations and the problems really changed the way people viewed risk behavior. So now we kind of shift gears and move to neuroeconomics. So one particular finding here is that decisions are influenced by emotions, like we've been talking about, and those emotions are associated with activity in specific areas of the brain. This was one study looking at neuroeconomics. So, in this particular study, they used an ultimatum game, and it was played with two individuals, and they were measuring brain activity. And they basically had offers going back and forth. And often they found that participants rejected low offers because they became angry that the offers were unfair. Now, in the conditions in which they had a computer as the other individual playing with them, they became less angry with the unfair computer than they did when it was an actual person. So here is a acceptance rate as a function of offer. So what we find is that people just in general were much more likely to take offers, even if they were low offers, from a computer rather than a human. And what they found in terms of brain activity here is that they found more activation of the right anterior insula. So this is connected to emotional states. And this happened when participants were more likely to reject offers. So this just kind of is giving us a physical demonstration of how emotion is important in decision making. Now we move on to a different type of reasoning. When we've been talking about inductive reasoning this whole lecture so far, now we move to something a bit different. We're looking at deductive reasoning. So this is more looking at things in terms of determining whether a conclusion logically follows the premises or what's coming before. So for example, if we look at a syllogism, we have two statements called premises. So two statements are made before, and then the third statement is called the conclusion. And the idea is to see if the third statement logically follows the first two statements. Now, we have things like categorical syllogisms, which are trying to describe the relation between two categories using the words all, no, or some, for example. Now, points to make about syllogism. First of all, syllogism is valid if the conclusion follows logically from its two premises. Now, if the two premises of a valid syllogism are true, so we know the two premises are true, then the syllogism's conclusion then must be true. But please don't confuse validity and truth here. They don't mean the same thing when we're looking at syllogisms. For example, if the logic is sound from the first two premises to the conclusion, then we can say the syllogism is valid. But that has nothing to do with the syllogism being truth. So make sure you take a look at this closer in your text. There's lots of different examples of syllogisms. So just make sure you understand that validity and truth are two different things when we're talking about this type of thing. Now, how well can people judge validity? Well, there are many errors in validation. So if we're thinking about syllogisms, again, we're thinking about these two premises following logically to a conclusion. And if that happens in a syllogism, we would say that the syllogism is valid. But how well do people really do that? How well can people really judge validity? And as you might imagine, there are lots of errors that happen. One thing that can happen is we have a belief bias. So this is just a tendency to think that a syllogism is valid if its conclusions are believable. So if we believe the conclusion, it seems somewhat believable, we might be likely to think it's valid and not really look at the logic tying premise 1 and 2 to the conclusion itself. Now, we can take a mental module approach to things like this. So we can take, for example, a specific situation and have it represented in a person's mind, and we can see if this helps to determine whether or not a syllogism is valid. So, for example, we would create a model of a situation and generate tentative conclusions about the model and look for exemptions to falsify the model and then determine whether or not the syllogism is valid. And this might be helpful by using this type of mental model for people to make a better determination of whether or not a syllogism is actually valid. Now, looking at conditional syllogisms, these are problems that you've probably seen a fair amount in standardized testing and things like that. So these are basically if-then problems. So if this happens, then this will happen. So for example, your book gives an example of, if I study, I'll get a good grade. I studied, therefore I'll get a good grade. So that's just one example of how a syllogism might work. And given those premises and how that goes through, you have to make a determination whether or not that is a valid conclusion. Now we can take this if-then logic from conditional syllogisms and use it in real-world problems. So this is the Wasson 4 card problem. And the idea here is to take 4 different cards and determine the minimum number of cards to turn over to test whether or not if there is a vowel on one side of the card, then there will be an even number on the other side. And this would be an example of the cards. So here's our 4 cards. And again, the idea is if there is a vowel on one side like this, a vowel, then there will be an even number on the other side. Now this brings us to a really important principle that a lot of people negate, and that is the falsification principle. So if we want to test this rule of if there is a vowel on one side, then there's an even number on the other side of the card. If we want to test that, then we want to go for a card that's going to falsify that rule rather than looking to verify the rule. Most participants fail to do this. Most participants want to verify the rule. So flip cards that are going to verify the rule. So look for whether or not it's true. They're not going to look at whether or not it's false. Now, when the problem is stated in more concrete everyday terms, people give a lot more correct responses, but in the Wasson 4 card problem, it's a very common thing that people fail to try to falsify the principle. Okay, so we take a look at the Wasson 4 card problem again. So again, we have the rule if vowel, then even number. As you can imagine, most people wanted to flip E. Now, again, if you flipped E and you found an even number, great. But all that means is that this rule is true for this one card. It doesn't mean anything about these other cards. Now, a lot of people also reported wanting to flip 4, but again, it's still the same thing. If the rule proves to be true, or really regardless of what we find on 4, it's not telling us overall about these cards in general, and if the rule is true in every case. It's only telling us if the rule is true in a single case. What we want to do is try to find a case in which this would be false. If we can find a false case, then that helps us determine overall whether or not the rule is true, because all we need is one false case to know if the rule is true or not. So what we should do is want to flip a 7. That would be what we would want to do. And if we find a vowel there, then this is not true. And we can say that this whole thing's false. Now, as always, make sure to read through your text very carefully. Make sure to take a look at permission schema at the very end of the chapter and the evolutionary approach to this 4-card problem. As always, please enjoy your reading and have a great week.